Hello and welcome learners. In the current session, we will discuss on the topic Measure of Central Tendency Part 3, which is the part of Unit 1 of course MST 002 Descriptive Statistics of PGDST program and Unit 5 of course BST CT 131 Descriptive Statistics and Probability Theory of BSc General in Statistics program. Myself, Professor MANISH TRIVEDI, Faculty in Statistics, School of Sciences, IGNOU, New Delhi. In the previous two sessions, Measure of Central Tendency Part 1 and Part 2, we have discussed about Measure of Central Tendency, Arithmetic Mean, various method of calculation of arithmetic mean. We have also discussed some properties of arithmetic mean along with the examples. The current session will explore weighted arithmetic mean. We will also discuss some examples based on missing values along with its application, merits and demerits. So, let us start with one example. We take here the case 1. If 5 students each of 25 kg and one teacher whose weight is 75 kg is given, so the simple mean would be the average of these two weights, that is 50 kg. But if numbers are also considered, then mean would be the 5 students, that is number 5 multiplied by 25, the weight of each student, and 1 into 75 kg, the weight of teachers, and divided by the total number, that is 6. So, now weight comes 33.33 kg, that is average weight. So, here average weight is inclined towards the 25 kg weight, that is where the numbers of students is more than the teacher, that is only 1. If we take the second case, 5 men each of 75 kg and one child whose weight is 25 kg. So, the simple mean is again, that is average of these two weight, that is 50 kg. But if numbers are also considered over here again, so 5 men of 75 kg, so we multiply 5 to 75 plus one child whose weight is 25 kg, so 1 multiplied by 25, so total weight is 400 kg and divided by 6 the number of men plus one child. So, here if we calculate the average weight, so that comes 66.66 kg. So, here the average weight is inclined towards the weight 75 more than the weight of one child, that is 25. So, here the numbers are playing the main role in average weight. Now, again we can take another example, the example of evolution methodology of PGDST program. So, in PGDST program, for each and every theory course, continuous assessment the weightage is 30% and term and examinations weightage is 70%. And if we assume that the mark of one candidate in continuous assessment he secure 80% and in term and examination he secure 60%. So, in that case if we calculate the average weight or average marks, so it would be 66%. So, here 66% comes and that is very near to the 60% which he secures in the term and examination. Why? Because the weightage of term and examination is 70%, that is more than the continuous assessment, whether he has secured more marks, that is 80% marks in the continuous assessment. Another case, if we take the for lab course in the bachelor degree program, the continuous assessment weightage is 70% and term and examination weightage is 30% in the lab courses. and if the same candidate secured 80% in continuous assessment and term end exams 60%, then the average marks he will get, that is 74%. So, here you can see in continuous assessment he secured 80% and weightage is 70%. So, then his average marks is very near to the 80%, that is continuous assessment marks. So, that means where the weight is larger, then the average marks will be more near to that amount. So, here we can see that we have calculated the two means. The arithmetic means we can say there may be calculated in two types. First one is simple arithmetic mean, where the simple arithmetic mean gives equal weight to all the items in the series. Weight here refers to the importance to a value in the distribution. And weighted arithmetic mean, that is weighted arithmetic mean gives relative importance, that is known as weights assigned to different items with the help of figures according to priority to all the items in the series. So, we can see that there are some cases where the relative importance of all items is not equal. A simple logic is that a number is as important in the distribution as the number of times it appears. So, the frequency of a number can also be its weight, but there may be other situations where we must determine the weight based on some other reasons. For example, a number of innings in which runs were made may be considered as weights because runs, that is 50, century and double century, show their own importance. Calculating the weighted mean of scores of several innings of a player, we may take the strength of the opponent as judged by the proportion of matches lost by a team against the opponent as the corresponding weight. So, higher the proportion, stronger would be the opponent and hence more would be the weight. So, we can say that it is wrong to give equal weight to different categories of employees in a firm, for example, manager, clerks and labor, etc., for calculating mean salary, as there may be only one manager, 30 clerks and 1000 laborers. So, in such cases, salaries paid should be weighted according to the relative importance, which may be the number of different category of employees in the firm. Therefore, weighted arithmetic mean is the correct tool for measuring the central tendency of the given observations in such cases. Here, the term weight stands for relative importance for different terms or observations. So, now we see here that how we can calculate the weighted arithmetic mean and what would be its formula. So, if x1, x2, x3 up to xk are the k distinct values in the variable x with the associated weights w1, w2, w3 up to wk respectively, then the weighted arithmetic mean or weighted mean would be the numerator term will be the sum of the product of the k distinct values with corresponding weights and divided by the sum of total weights, where that is equal to summation of I is equal to 1 to k wi xi summation divided by summation of wi, where wi stands for the known weights assigned to the different distinct value xi. Now, we come to an example which would give more clarity about the weighted mean. So, if there are three types of workers, men, women and children which are more than 12 years working on a construction of a building. So, if we have to find out the average wage per day, if a man paid rupees 120, woman paid rupees 100 and child paid rupees 80. So, in that case, to highlight the importance of weights in such examples, let us consider the following three situations. First situation, where simple arithmetic mean of the wages is calculated. So, that is the sum of all the wages divided by the total type of wages. So, the sum of wages is 120 plus 100 plus 80 divided by 3. So, the average wage per day is 100 rupees, that is the simple arithmetic mean over here. Now, if we take the second case, that weighted mean with equal weights. So, here it is assumed that there are equal number of workers each type, say 40 men, 40 women and 40 children. The calculation needed to get weighted mean in the situations are, that is, we have multiplied the values, that is their wages 120, 100 and 80 rupees with the number of workers, that is 40, 40 and 40. So, 40 multiplied by 120 plus 40 multiplied by 100 plus 40 multiplied by 80 divided by the total number of workers, that is 40 plus 40 plus 40 and that is 120. So, here the average wage comes 100 rupees per day. So, in the above two cases, we observe that the simple arithmetic mean and the weighted mean with equal weight results in the same answer, that is 100 rupees per day. However, the above two situations are far from the practical situations and the number of workers or employee generally vary in different category. So, this varying number of workers in different categories should have its impact on the mean. To show this impact, in the present example, let us suppose that the number of men is 80, number of women is 40 and number of children is 25 respectively. So, now the weighted average can be calculated and the answer would be different. So, if we calculate the weighted arithmetic mean in that situation, so 120 into 80 plus 100 into 40 plus 80 into 25 would be the total in the numerator term and it is divided by the total number of workers, that is 80 men, 40 women and 25 children, that is 145. So, the total of numerator is 15,600 and it is divided by 145. So, it has come 107.59 per day. So, here because of the number of men and women are more than the number of children. So, the average price, average wage is more nearer to the 120 and 100 in spite of the 80. So, in that case, now we take another example here, that if we calculate the simple and arithmetic weighted arithmetic mean for the first n natural numbers and the weights we are considering over here will be the corresponding numbers only. So, the first natural numbers 1, 2, 3 up to n, it is given in the table, weight are the same as the numbers 1, 2, 3 up to n. So, the addition of these n numbers, we know that it is n into n plus 1 divided by 2, and if we multiply both x and corresponding weight. So, Wx, that is 1 square, 2 square, 3 square up to n square, and if we add these squares, so the addition is n plus 1, 2n plus 1 divided by 6, that we know. So, the simple arithmetic mean would be, that is addition of n numbers divided by the total numbers small n. So, it is n plus 1 divided by 2, but if we calculate the weighted arithmetic mean, so weighted arithmetic mean comes here, we take the Wx summation Wx divided by summation of W, that is the weight. So, it comes 1 square plus 2 squares plus up to the sum of n square and divided by the total numbers. So, then the weighted mean comes 2n plus 1 divided by 3. So, now after discussing the weighted arithmetic mean, now we take some examples of simple arithmetic mean which are related to the missing values and missing frequencies. Let us take first example. So, it is given, a distribution is given over here on the x values and the frequency of corresponding to the values are also given. Arithmetic mean is given 9.41, but here in that data one value of x variable is missing. So, the value in the table, if we see, x values are 5, 8, 9 and one missing value and 13 is given. So, let us the missing value we buy, and then the second column we have taken the corresponding frequency. If we multiply for obtaining the arithmetic mean, we have to get the sum of x and f. So, we multiply x values to corresponding frequency, and in third column we get the fx values. So, first value is 40, second value is 160, third is 9 times 30, that is 270, and next because the missing value is y. So, and the frequency of that missing value comes 25. So, that is 25y, and then 13 multiplied 70. So, it has come 221. So, summation of fx we have calculated over here, that is 691 plus 25y, because this value we do not know, and sum of all the observation is 100. So, now if we calculate the if we see the formula, so summation fx divided by capital N, sum of all the frequencies. So, in numerator we put the value of summation fx 691 plus 25y divided by 100, and x bar is given, that is 9.41. So, after some algebraic manipulation we obtain the missing value y, that is 10. So, in this manner we can calculate, we can find out the missing value of a data if the arithmetic mean is given and the frequencies of all the values is given. Then the next example, here the example we have taken where the classes of weekly wages is given and the number of workers, that is frequency of first 3 class is given, but the frequency of 4th class is missing and the frequency of 5th class is also given, and it is also known that the mean of frequency distribution is 47.2. So, in that case how we find the missing frequency? So, let us see that in the table. Let the missing frequency is f1. So, in first column the classes is given, and in this case when the classes is given we calculate, we obtain the mid value, that is x value in the next column. So, that comes 41.5, 44.5, 47.5, 50.5, 53.5, and in next column the frequency is given where one of the frequency is missing, that is f1. So, here the total of all the frequency comes capital N equal to 176 plus f1. Now, di value, that is deviation values, is calculated in the 4th column, that is we have selected 47.5 as the assumed mean, and then we have taken the deviation from the x values and divided by 3 as the class interval is 3. So, and multiplied in the next column these deviations with corresponding frequencies. So, the sum of multiplication of frequencies with the corresponding deviations is comes over here f1 minus 66. Now, here if we put these values, summation of f d dash, h that is class interval, a that is assumed mean, and capital N the total of all the frequencies in the formula. So, and x bar is also given, that is 47.5. So, after some simple algebraic manipulation, we can get over here the f1, the missing frequency value, that is 44 in this case. So, this is the method that if we have a missing frequency problem, then we can get the missing frequency value in that manner, that we calculate all the total of all frequencies and total of the sum of multiplication of the deviations with their corresponding frequencies and put the value and can get the missing frequencies. So, we have seen over here the example of one missing frequency example. In next example, we may face problem where two of the frequencies are missing and the total of all the frequencies is given and average value, that is arithmetic mean value, may be given. So, in that case, let us see in the table that x values is given in the column, first column, that is 0, 1, 2, 3, 4 and 5, and corresponding frequency is 23. The frequency of values 1 and 2 is missing. So, let it be f1 and f2. Frequency of 3, 4 and 5 numbers is given 12, 5 and 3. So, the total of frequency is also given, that is 100. So, now from this column we can see that the sum of all the frequency is 100 and this is 43, the total of all the frequencies are given of numbers 0, 3, 4 and 5 and plus the missing frequency f1 plus f2. So, from here we can obtain an equation, that is f1 plus f2, that is sum of the two missing frequencies is equal to 57. Now, for the given formula of arithmetic mean, we need summation of fx in the numerator and sum of all the values, that total frequency in the denominator. So, now we can obtain in the third column, you can see that we multiply the x values with the corresponding frequencies and we can get the sum of summation fx, and in this case it is 71 plus f1 plus 2f2. So, after putting this summation of fx in the mean value in the mean formula, we can get the equation that f1 plus 2 times of f2 is equal to 79. So, the first equation was f1 plus f2 equal to 57 and the second equation we got here, that is f1 plus 2 f2 equal to 79, and if we put the f1 plus f2 value from the first equation in the second equation, we can get the f2 values is equal to 22, and after getting the second frequency value, that is 22, if we put the f2 value in the equation number 1, we can get the frequency, that is first frequency f1 value, that is 35. So, in this manner we can get the two missing frequency, we can obtain the missing frequencies if the total number of frequencies is given in the data and arithmetic mean value is also given. So, examples we have considered over here of missing frequencies. Now, we come to the applications of arithmetic mean. So, generally arithmetic mean is the best average for all purposes and should always be preferred unless there is a definite reason for considering another example or another average. Arithmetic mean is preferred as it is capable of further algebraic treatment and has the maximum sampling stability. It is always recommended in situation where the data properly spread out, that is they are homogeneous in nature. It is also used in further statistical analysis like measures of variation, correlation, regression, in testing of hypothesis, mainly in parametric tests, ANOVA tests, sampling techniques, design of experiment and multivariate, etc., etc. Now, we can see that the merits of arithmetic mean. So, we can say that the calculation of arithmetic mean is quite simple if all the values of the variable are clearly defined. The formula does not require too many steps for computation of mean. This measure of central tendency is a well defined measure and does not involve any ambiguities, although there are different methods we have already discussed in last our presentations in the text, but all of them when simplified reduce the basic formula, and that is sum of all the values divided by total number of values. It is generally seen that it is least affected due to the sampling fluctuations. In this sense, it is known to be a robust measure of central tendency. Mean is only measure which is defined based on all observations of the variable. In this sense, mean is the best measures. Arithmetic mean also have some demerits. Mean cannot be calculated if in a frequency distribution there are some open ended class intervals, since in such cases the mid value of the classes cannot be determined. Similarly, mean is highly affected by extreme values of the data, which are generally called outliers. This illustrates that mean is not an appropriate measure of central tendency if outliers are present in the data set. It cannot be located graphically and it gives misleading conclusions sometimes. Now, we summarize here our session. So, we have seen that simple arithmetic mean gives equal weights to all the items in the series, where weight refers to the importance of a value in a distribution. Weighted arithmetic mean is used in cases where the relative importance of all items is not equal. Weighted arithmetic mean gives relative importance assigned to different items according to priority, that is known as weights, to all the items in the series. We have discussed the examples related to the missing values in the data. We have also discussed the examples related to one missing frequency data and two missing frequency data. Applications are also discussed with merits and demerits of arithmetic mean. Thank you.